Well, hello everybody. Welcome to 10-9. This time I have 5 guests with me. Let's see, I have 2 guests from the 6-3 class. I have 2 guests from the 6-2 class and 1 guest from the 6-1 class. And we're going to go over the rest of the different kinds of volumes you're going to be responsible for. So you should already have finished your 10-7 classwork from today. And that was where we were finding the volumes of cylinders and prisms. Okay? And so, very quickly, we know that when we have cylinders or prisms, those are these guys up here, the volume is just equal to base times height. Not a big deal, right? And so get that 10-7 classwork homework done if you have not already done it. What we're going to do today is we're going to add a couple more formulas for volume. We're going to add the volume of a sphere, and we're going to add the volume formula for the pointy things, the cones and the pyramids. We're still not going to mess around with surface area for the pointy things, but we are going to do the volumes, and you'll see why when you see the formula. All right, so real quickly, if you have the volume of a sphere, okay, we talked about this in some of the classes today. All round things always have a pi in the formula, and anything having to do with circles also has a radius in the formula. And if we're doing volume, the variable is going to have to be cubed. So for pi r cubed was probably a good guess for the volume formula for a sphere. The problem is that doesn't quite get us there. We actually have to multiply by 4/3 as well. So there is the formula, and that's kind of where it comes from. So for instance, if I gave you a radius of 5 and you plugged it in, you get 4/3 times pi r cubed. You write the formula out, same as before. Same exact thing we've been doing all through this chapter, right? Check mark. Yeah. We're going to plug in a 5 for the radius. Okay? Check mark. And now we're going to do the math. So 5 times 5 is?
25.
Good. And 25 times 5 is?
$125.
$1.25 if you're thinking money, so it's 125. 4/3 times 125 times pi, if you do that all out on a calculator, use 3.14. You're going to get about 523. Oh, I didn't tell you what kind of units. So, no, we're just going to use units cubed. I don't know what the units are, but I don't need to know what they are as long as I don't leave it naked. All right, so let's go right to the pointy things, the prisms and the cones.
Mr. Gunn.
All right, yes?
How does the formula work for both of them? Like, that one has a bunch
Yeah, so interestingly enough, if you have a pyramid or a cone, well, let's think about it. Didn't you have the exact same formula for the area of a prism as the area for a cylinder?
Yes, sir.
So it didn't really matter what the bottom shape was. All you did is take the base area, this part that's underlined in red, you took the base area multiplied by the height. Turns out that when you go up to a point, which one of my guests just pointed out, the fancy name for the point at the top is called the
vertex.
The vertex point. When you go up to a point, you lose about 2/3 of the volume.
Yeah.
Take a look at the blue cylinder.
It's easy to
all right?
see.
So if I have this yellow cone inside the blue cylinder, you can see all that extra area around the top that's going to get chopped out. It's going to be about 2/3 of the volume. So all that's going to be left behind for the cone is 1/3. It turns out that the pyramid is exactly the same amount of loss. You lose about 2/3 of the volume around the top. So the actual why and the proof that it's exactly 1/3 the base and the height, that's a little hard. But here's the thing. If I give you a formula and tell you how it works, you should be able to use it. And from today's classwork, this is why I kind of skipped from 10-7 right to 10-9. If you already know how to do base times height, which is what you did for prisms and cylinders, all you have to do for pointy things like cones and pyramids is take 1/3 of the answer you got for the 10-7 homework. That's it.
Could you divide by 3 to just make it easy?
Now, another way to say that, if you want to think of that as B, whoops, that's not the right pen. If you want to think of that as BH over 3, that is the same thing. That is very true. And that's it. That is literally all there is to this lesson. Wouldn't it be awesome if we had less minutes than guests? All right, so very quickly, if you haven't guessed them already, my guests are as follows. We have some stylist challenges here, but we've got Reed from the 6-3 class. You can say hi.
Hi.
Hello!
We've got Smith from 6-2.
Hi.
You better hurry up. We only got 8 seconds.
Go,
We got Chase
Put
from 6-1.
6-3.
6-3. Sorry. Oh yeah, I knew that.
Oh,
Camera.
We got Camera on from 6-1, and last but certainly not least, we have
Come on.
Crazy Boy in the flesh, Mr. Seth.
What's up?
All right.
Hey,
And thank you very much for
Hey.
watching. That's enough doodling on my
Thank
stuff.
you.
All
Yay.
right, so guys, it's real simple. Follow the formula, plug in the numbers just like you did before, and show your work. That is all we have for you tonight.
Do your work.